Alright, tonight we have this A1989 which randomly stopped turning on. So let's go ahead and see what this does. Let's go ahead and plug in our USB-C amp meter as usual. And we are taking 5 volts and 0.1 milliamps. I don't know if you can see that there, but that could mean a few different things on these boards. Behind door number 1 is a T2 chip issue. Behind door number 2 is usually a PP bus short, which is common. So I'm going to go ahead and immediately unplug the battery and check if I have a short on PP bus G3 hot, so we could rule that out. So our PP bus G3 hot fuse is going to be over here, and I have it's over here. I have no short to ground on PP bus, so it is not that. Next thing I'm going to go ahead and do is plug this machine into my computer to see if it is in DFU mode. So let me do that now. As you can see, this device is not detected in DFU mode, so that means we have a totally different issue somewhere else. Let's go ahead and give the device a very brief visual inspection before pulling the board. So I want to have a look around my USB-C controllers, near my CPU area, and so far everything looks pretty clean. I don't see anything wrong here. The device does not look like it was liquid damaged at all. Go over by our PMIC and look at this. So this chip is our PMU. This is responsible for a lot of different things. This is responsible for outputting many different voltages on the board, and obviously this does not look normal. So this right here is a very obvious burn mark on it. So this is no good. This could have killed many other different rails on this system. Hopefully it's just a short within that chip, but this is very clearly burned. So best case scenario, it just killed the PMIC is the only thing dead. Worst case scenario is the PMIC took out the T2 chip, in addition to probably some other stuff, if it failed in a way that sent voltages elsewhere. It kind of looks like maybe the clock portion failed, so maybe the clock supply voltage was the only thing that died in it. But we're going to change this, and we're going to see what it does. Let's go ahead and get this board out of the enclosure and see if there's anything else that might have caused that, and then go ahead and replace this chip here. Motherboard is out. Let's go ahead and have a look under the scope. The main thing I want to look at right now is to see if there's something that may have caused this PMIC to die. So some random corroded component that could have spiked voltage to align for the PMIC, something like that, and it looks pretty clean. Yeah, this board does not look like it was liquid damage, so what probably happened is just that PMIC developed an internal short to ground and decided to die. That's pretty rare. We don't see a lot of failures on these unless there's liquid damage. But let's go ahead and pull this off. This is an Apple part number. This is an Apple chip, so the only source on this is going to be another board. These are not paired to the board either, so you could use one from any board that has this. Get a better pair of tweezers here. Looks like our solder balls are intact, and that was fairly important. Let's see if we could see anything on the bottom side of this chip, because this is basically the die under here. So a lot of times chips will have, oh, look at that. So we could actually see the die under here. So this is the actual die that the chip that all the balls are connected to. That's directly to the die. Let's see. Yeah, that has seen better days. So whatever portion of this, whatever portion of the chip this is right here, just totally burned here. Let's see if we can maybe scrape some of this acrylic off to see the dye. Yeah, it's just burned. Hard to see. That's definitely where the failure was. So let's go ahead and reball a new one of these and get it on the board. These are kind of a pain to reball, so I kind of want to leave some of the balls behind just so it kind of aligns itself with the stencil and it just kind of keeps it in place. So I am going to just get rid of the bridges or any balls I don't like here. So that's like this one right here. So let our iron get hot. Looks like that was the only bridge. So the rest of these should work out just fine. Looks like all the other pads are in decent condition too. So we'll go ahead and put our stencil over this. Looks like we need to clean our stencil a bit. So I could just do that with my hot air. I actually have a little portion of this stencil specifically for these PMICs. Looks like I might be off by one row. And I was. Reballing is probably my least favorite part of the job. Actually, I take that back. Reballing isn't that bad. My least favorite part of the job is probably dealing with people who are unreasonable. Can't tell if this is if I had it aligned or not. Maybe my captain tape is off. Let's see, where's our chip? Wouldn't help if the chip sticks in the stencil the second it touches it. Nope, that's as good as it's going to get. It's just my captain tape is off a bit. Let me just move this over so we don't have any excess balls, because it tends to, if you get any that runs over, it tends to make a nightmare. So we're going to push this down so it's seated on the balls that are there. Let's go ahead and get our solder paste. Before somebody asks in the comments, I am using Amtech Syntech. This is 6337. It's really, really good stuff. I recommend it. It really works phenomenally. In addition, what I'm going to do is I'm going to dry a little bit out. I want to dry it a little bit out. And how I do this, the reason why I do this is dried solder paste tends to, does not jump out of the stencil holes as easy as wet solder paste. So this is simple to do this. All you need to do is get a paper towel or anything, could be really anything. I use a paper towel because it's disposable. And then you're going to get your flux, your solder, push a little bit out. I forgot where my plunger is for this, so I'm just going to use my tweezers. I'm going to push out the amount that I think I'll need, like that. So we have just a little bit on paper towel. Then I'm going to get my hot air at 100 Celsius and just heat it until the flux burns away a little bit. We don't want to heat it too much, or else the paper towel will burn, and two, you'll melt the solder, and we don't want that. So we just want to kind of burn that flux away a little bit, just so it's a little bit easier to manage. Now keep in mind, this is just my way of doing it. It is not necessarily the best way to do it, and if you have something that works better, you should do it in the way that works for you. This is particularly how it works for me, and that's why I do it this way. So I'm going to get, where did that go? Here it is. I'm going to get some solder paste over here, then I'm just going to spread it around with a whatever flat tool really works. It doesn't have to be anything specific, as long as it can get those that solder paste in those holes. A little bit more. So we have some right here. Sometimes there's not enough in there and it's hard to see, so I just want to make sure that it's sufficient so we don't have to come back later. And I think it is. So I'm going to go ahead and clean the immediate area up around here. And then this is a very thin stencil. So how you can get around this is putting a piece of glass over the stencil and heating the glass. This does two things. One, it minimizes high heat exposure directly to the chip, which you don't necessarily want. And two, it will keep your stencil it'll keep the stencil from warping under heat and keep it flush to the chip flush to the stencil. So we're going to go ahead and set our hot air. My particular settings, I use around 300 Celsius and about 50 liters per minute of air. I'm going to push down right here. I'm going to heat the glass. It's important to keep pressure down. And once you see all the balls are formed, you can go ahead and lift pressure away like that. And we're going to let the solder balls harden, and then we're going to pull the stencil off. And that doesn't look too bad, but we did miss a couple, so we're going to have to take another run. I just want to flow these into place. The dark areas are just flux. That doesn't mean anything. It's not burned or anything. So we just have a couple that we missed. All the rest look really, really good. So I am just going to put this back in the stencil and just put solder where I need it to go, and then we should be good to go. Little note here, these chips are usually only limited to 2 or 3 soldering cycles, so be careful on your heat here. Don't overheat the chip. As long as you're not stupid, you should be okay, and they're always rated for a little bit higher than what they can actually sustain. I mean, they're always rated a little bit lower than what they could actually sustain, so you're okay if you solder the chip 2 or 3 times. Just be careful. In addition, chips themselves are static sensitives. Boards are really not, so make sure you ground yourself before touching these. So by that, I just mean touch something that's connected to ground. Nothing too crazy. So to do these, I'm just going to get a little more of my solder paste on my tweezer, because we don't need to put it over a vast area. Helps to have 2 tweezers. And just fill in around the area that you missed. Just like that. Same thing as before, cover it with a piece of glass. Heat, 350 in my case. 300 Celsius, 50 airflow is what I mean on my quick. The actual temperature the chip is exposed to is a lot lower than what's at the nozzle through the glass, so this is another thing why I use the glass, as it kind of helps our chip stay within its soldering parameters as far as heat goes, because most chips are only rated for like 230 degrees Celsius, and that's at the die, that's at T-junction, that's not your hot air temperature, because there's always going to be some loss there. So just to note that, because I see a lot of people like reballing chips at like 500 Celsius or something, and that's too hot, and It's different if you're soldering a chip to the board because it's not going to fully reach that temperature, but reballing when the chip has no thermal mass, then yeah, you will reach that and that will be a problem. So these look good to go. Not too worried about the flux. We'll clean that up later. Let's go ahead and prep our board for soldering this on. So here's our board. Here's our PMIC area. Hopefully there's no damage to the balls under here or to the pads or traces. That's a little bit of my concern, but I think we'll be all right. So get some flux. As always, a tin tip. Get rid of all this stuff first. And not good. We have a broken pad right here. That's not good at all. That's not good at all. Let's go ahead and get some wick, and hopefully this will clean up. I want to feed a bunch of leaded in here. Hopefully that's just a ground pad or something, because that's not going to be good if it's actually a burn pad on something important. You can feel how it's all charred. Let's trim our wick back a little bit. That was probably an NC. We'll double check. The way it just fell off, it makes me think it was an NC. Yeah, you have to kind of be careful on this chip because the thermal mass is so high and it is kind of hard to wick. So you have to be careful. Looks like we lost two. Likely NCs. Let's clean this up. So we have a bunch. What probably happened is the chip got so hot that it just, those little NC pads are only held on by a little bit of adhesive. So my guess is that those came off really easy. So my guess is that chip was just so blazing hot that there were just nothing holding those on. Let me check the board view real quick. So this is an A1989, I believe. Let me pull that up here and then I'll show you guys as well. All right. Here's our PMIC, and you can see it does have a lot of unconnected, and looks like all the ones that we got are NC, except maybe for, let's see. This isn't one thing I like to show people because some people, when they rip a pad, they panic, and that's not good. 1, 2, 3, 4, 5, 6, 7, 8. So 8 in and 4 up. So 8 in and 4 up. So 1, 2, 3, 4, 5, 6, 7, 8, and 4 up is an NC as well. Now, what is that burned one up here? So the burned one is 1, 2, 3, 4, 5, 6, 7. 7 in and 3 down. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. 3v3G3 hot. Of course it was 3v3G3 hot, but it's connected to right here, so I'm not going to worry about it too much. What we should be able to do is just leave that alone and it should be fine. There's still going to be power going through there. Maybe it won't carry as much current as it did, but it should be okay. So if I can bridge it to the one next to it, I will, but if I can't, having a free wire under here is much more risk than the risk that it would be of leaving that off. So let's see, can I get a little bridge in here? No, I'm gonna leave it. And the one next to it is what? PP3V3 VIN. So this one's okay. This one has a little bridge. Yeah, I'm gonna leave this alone because, like I said, if I have a wire under here and that shorts to something, or if that moves, especially with how big of a chip this is, we have serious problems, and it's just not worth taking that risk here. Let me just make sure the VIA is connected. I could check that over near our battery connector. So our battery connector, this cap, I believe. Yep, and we are connected. So I'm going to go ahead and drop this chip in place, and then we'll try it. Hopefully all will be good. I really don't think that that chip is going to use enough current that one ball would not be sufficient. It's more of just a fail-safe kind of thing, so I'm not going to worry about it too much. Another thing, when we're soldering a big BGA like this, we're going to put some flux down and we're going to spread it around. We do not want too much here because the chip will float away. And alignment is fairly difficult on a chip like this, so I am just going to thinly spread this out. Could even use our hot air to kind of melt it at a low temperature, of course. We just want a thin layer on all the pads. I see a lot of people use a ton, including myself, on certain BGAs, and that's not the right way to do it. You just want a thin layer on BGAs. Smaller BGAs doesn't really matter, but bigger ones like this, it's hard to tell if it moves over a little bit, and if it moves over, obviously you have a little bit of a problem. Especially in like a CPU or PCH or PMIC like this is. Let's go ahead and place our new chip. Let's double check orientation. I believe that the dot should be in the bottom corner here. And it is according to the board view. So let's go ahead and drop this down here. We are going to go low on the heat. We're going to go about 300 Celsius. Then go up from there because, as I said prior, stuff like this is fairly sensitive to heat. Should be aligned all right. So we'll go 300 Celsius at 15 liters per minute of air and get a nice preheat on there. And then if the balls do not melt, we will go up. Longer heat or lower heat, the longer we'll have to be on there, but I'll take that over higher heat on a BGA like this, because this is basically, it's an integrated power controller. It has a microcontroller. It's like a little CPU in this, so it is fairly sensitive to heat. It's not really the silicon you have to worry about. It's the bond wires and everything else. So I'm tapping components around it to see if they're melting. But I think now we have enough of a preheat. We could go up in temperature and complete the, let's see, it just moved over. Likely aligned itself. And I think that's good and aligned there. Yep, that looks to be good. Let's go ahead and let it cool down a second, and then we'll try it and see what happens. Alright, so if we get to a booting current of 55 to 60 milliamps, this should be fixed. So let's see. Heck, even if we get to 20 volts, that's a good sign. So 5 volts, 22 milliamps, 20 volts, and 19 milliamps, 36 milliamps, 54 milliamps, 43, and our heatsink is warm. So let's go ahead and see if this is actually booting. Sometimes if there's an issue with the T2 or the PMIC, it'll just be brain dead because it's missing some rail for the RAM or EDRAM or something like that that has to be enabled by the PMIC. So let's go ahead and throw this back in the enclosure and see what it does from there. My guess is it's going to be working because 55 milliamps is a pretty good predictor that the board is actually in a SO state and working. So let's go ahead and do that now, and then we'll be right back. All right, let's see what we get. So charger's plugged in. Let's see if I get a trackpad click. Trackpad is clicking. That means the T2 chip is alive because the T2 chip is what controls that click thing. Just an actuator. And that is an Apple logo. So that's a very good sign here. Let's see if it actually boots fully. Again, for everything to be working, we need to get past about 3/4 of the way through the Apple logo. If it hangs before then, you got something wrong. Could be a board level issue. But I think this will be all right. I also want to cover this just in case. I don't want to reveal any customers' names. And sometimes they are starting they do start in recovery, which is somewhat normal if it stopped working during boot or an update or something like that. So I can go ahead and let this boot fully. And of course, recovery mode as usual whenever I'm trying to do a video of something booting. So it is fully booting now into the OS. And we're good to go here. So this was a bad PMU, which is a semi-rare fault. We don't often see these, especially without liquid damage. Everything's connected except for the speaker assemblies, and this is working good. We're not going to ultrasonic it. I don't like to ultrasonic a board unless I have to. If it has liquid damage, we'd only use a little bit amount of flux around the chip, so Q-tip and alcohol should be fine for that. Again, it's not a big deal if you leave a little bit of flux on the board. Flux is flux. It's not going to hurt anything unless it's on a high voltage circuit, and this is not. But this is good to go. So yeah, thank you for watching, and I hope this video helps you solve your problem in some way. I hope that those tips on reballing helps on bigger chips like this, and that's it for tonight.